serious. Good afternoon once again. My name is Diya'uddeen Basheer Hassan. We'll be talking about petroleum refinery effluents and their treatments. Actually, petroleum refinery effluent from the name is the wastewater generated from treatment of crude oil, and it is obtained in the refineries. Now, all of us know crude oil and its composition, which is highly organic components with inorganic constituents. Now, if you process crude oil, you are going to generate a lot of waste. That is one of the peculiar aspects of wastewaters from refinery, because they have complex and numerous organic components. We have phenol, benzene, toluene, and a lot of them, more than 20. Due to technicalities, we will not be talking about them. Now we talk about what is so special about refinery wastewater. We have many wastewaters from various places. Refinery from wastewaters are different because they are classified as priority pollutants. Not only they are priority pollutants, but individual components in the petroleum refinery effluents are also priority pollutants. So now if you sum up the individual components, what you have is a very high priority pollutant wastewater generated from refineries due to processing of this crude oil. Okay, you have what we call it wastewater, which is what we call it priority pollutants. Are we the first to treat it? No. The treatment has been going there for a very long time. You have many techniques that have been used. The difference between the new technique we are proposing is that all the other techniques, all the techniques, they don't degrade completely. That is why. Now, if you have things like phenol and you don't degrade them completely, because if phenol breaks down, it generates a lot of byproducts. Each of the byproducts, again, is a pollutant. For instance, phenol, if it degrades, you have xylene, creosote, and many of them, BTEX. Each of them, again, is a priority pollutant. So our new technique, which we call advanced oxidation processes, they degrade and mineralizes, which means it breaks them down and eliminates them into byproducts that are environmentally benign, which are what? CO2 and water. So anytime you have CO2 and water, you can be safe instead of having discharges which are byproducts that are dangerous. Now, to establish what I'm saying, and to say it is a fact because we are an academic community, we established that before these processes are not being used in the industry. I happen to have the opportunity of visiting most of the refineries in Malaysia. I was in Port Dickson, I was in Malaya, I was in a number of places, and I did work in the petroleum industry. No other place is using this on industrial scale. So what we want to tell the industry is that we from the academia, we are going to establish this process as a viable technique for using to treat petroleum refinery effluents, period. The next thing is, how do we do it? These advanced oxidation techniques, they use what we call hydroxyl radical. Now, hydroxyl radical has a very high oxidizing potential of about 2.7. So technically speaking,